Hey guys, welcome back to another lesson on geometric expressions. My name is Miss Danielson, and today we're going to be looking at the areas of rectangles and writing algebraic expressions to represent them. That will involve using brackets. So I hope you joined us for our previous lesson on expanding brackets, as well as our previous lesson on writing expressions for the perimeters of rectangles, because both of those might come in handy here. Let's get started. First of all, the area of a rectangle is measured in squared units of measure. Now this is something I hope you already know, but let me just clarify this again with a diagram. So if I've got a rectangle which is 5 centimeters by 3 centimeters, I can fill the space inside the rectangle with centimeter squares. I'll start with one row of 5 centimeter squares. And as you can see, I've got space up the side of the rectangle to repeat that row 3 times. Altogether, I've got 3 rows of 5 centimeters squared, which is why the area of a rectangle is length times width, my length being the 5 and my width being the 3. The formula could be written just using variables, so letters, to represent the numbers. So A, the area of a rectangle, is always L, which is the length, multiplied by W, which is the width. So in this case, A is equal to 5 times 3, which is 15 centimeters squared. Now it's really important that you remember that areas are measured in units squared. That's why we've got this 2 here, because it's a two-dimensional shape. If I were to say that the area of this rectangle were just 15 centimeters, that would just be a one-dimensional measure, a straight line 15 centimeters long. That is not the kind of unit that will fill a shape. Let's move on to an algebraic example now, where we don't know some value. In this rectangle, I can see that the width is 3 centimeters, but the length is 2 plus x centimeters. Suppose I didn't have a long enough ruler to measure the full length of this rectangle. So I used some other unit. Maybe I just used my hand and saw that it was 2 centimeters more than the length of my hand. Or maybe I used a book and I said this is 2 centimeters more than the length of the book. But I don't know what the length of x is. In that case, I need to set up the formula for the area of a rectangle and substitute into that formula the width being 3, but the length being this expression 2 plus x. If you joined us for expanding brackets, you'll be more familiar with seeing brackets multiplied by some term that is written directly in front of it. So a equals 3 bracket 2 plus x. And remember, we don't need to write the multiplication sign to show that the term in front of a bracket is being multiplied by all of the terms inside the bracket. Again, let's use our diagram to explain why we multiply 3 by all the terms inside the bracket. So although I don't know what the length of this rectangle is, I know that it is 2 centimeters plus some unknown length. That's the length across the bottom, and I could repeat that 3 times up the side. So 2 centimeters and some unknown length, 2 centimeters and some unknown length. Altogether, I've got 3 sets of 2 centimeters in each of these rows. I've also got 3 sets of this unknown length, so 3 times this x length. So to multiply this out, if you remember from our expanding the brackets lesson, we follow the rainbow. First we do 3 times the first term, 3 times 2 is 6, and then we do 3 times the last term, 3 times x is 3x. And remember that this is measured in squared units. So if my length was 2 plus x centimeters and my width was 3 centimeters, my area is in centimeters squared. Note I don't use the units of measure in my calculations so as not to confuse the centimeters as being some variable c and m. Let's go into some practice now. Go ahead and copy these diagrams and label them as you see them labeled here. Clearly they don't need to be drawn to scale because you don't know what their lengths or widths are. Just go ahead and draw rectangles that look similar to these and work out your expressions for the area. Hit pause and give that a go now, and hit play when you're ready to take up your answers. I hope you've had a chance to hit pause. Here come your answers. For question A, first I'll set up my expression and then I'll expand that bracket out. For question B, again, there's my expression. Remember, we multiply number by number and letter by letter. And there I've expanded it out to simplify. Question C, and expanded. Question D, and expanded. E, and expanded. F, G, and expanded. Note that when I did 9F times 4FG, I did number times number, 9 times 4 is 36, and letter times letter, F times F made F squared, and the G, it's just multiplied by the F squared. H, and expanded. This time it may look like I am squaring 46hi, but the power of 2 is only touching the I variable, so it's only the I value that's been squared. This has been just a very quick lesson on expanding brackets and area expressions. I hope you found it helpful and got some good practice out of this exercise. If you're finding you still need to go through a lesson on this, please check the description box down below where I've linked expanding brackets, perimeter expressions, and simplifying expressions. Until next time, keep practicing, and I'll see you soon.